In the last video, we discussed about this question, number of islands, and we discussed the theory behind it and how we will approach it and do it. And in this video, I will code it up live and let's see if I'm able to code it up or I make any mistake. The approach that we discussed in the last video was that whenever we encounter a 1, we mark it as 2 and we recursively do the DFS on every node that is connected to that 1, and hence that whole component will be marked as 2. And when that whole component is marked as 2, we can then continue and try to find another one which is 1, and we then again call a DFS on that and we mark the whole component as 2, and we will continue to do so until every one is exhausted. And the number of times we actually start the DFS, the number of times we actually encounter the 1, we can simply say the number of times we encounter once is the number of times we run a DFS call on the whole component, and it is the number of times we are seeing an island. So whenever we see an island, you can say that whenever we see an island, we destroy the whole island. So whenever we see a group of ones, we destroy it. We make it 0 or we make it as 2, and we will do this. We will repeat this process again and again until everything is visited. Now, what is the complexity of this process? Whenever we start at 1, and like for example in this example 1, we simply start a loop for every cell. Now when we start from this cell, and we will obviously mark everything, this whole component will be marked as this one and this one also, since this is connected to this one on the first row and these two ones. So everyone here will be marked as visited, and the number of components is 1. And so what we are doing is that we are just doing a loop through the whole 2D matrix. And since we started the DFS at this first one here and it marked everything as 2, as every one as 2, now when we come to this one, we see that it is already marked as 2. Now when it is already marked as 2, we know that this must be a part of some component which we have visited in the past, and hence this whole component is visited. No need to start the DFS again, no need to start it. So number of islands is the number of times we make the DFS call. It is the number of times we encounter 1 while traversing the whole 2D grid. So the complexity will be n into m for traversing the whole grid, and n into m for the DFS call. N into m, or even if we are more accurate, it is the number of ones, because the DFS will continue till it sees all the ones and it destroys all the ones, and it will move on them, and it will stop when it doesn't see anyone. And this is the complexity. And just to see a rundown, for example, this is the grid. We start a loop, we visit this one first and we mark that as 2, and then mark the whole component as 2. Now we visit the second one, we again mark it as, we see that it is already marked 2, so no need to start marking it anything, and continue to traverse the whole grid. Now when we encounter this one, we again know that okay, so this is a whole new component, this is not part of this component, else if it had been part of the first component, it would be 2 already, but since it is not, it is a whole new component altogether, so this is also marked as 2. Hence the number of times we made the DFS call is 2 times, and we just keep the count of this and we return that count. And yeah, let's start coding. So the first thing I like to do is like separate out the grid size in one variable, and if the time permits, I will also try to code this in Golang, because as I said, I will also be explaining Golang in these videos, and hopefully if you can learn some of it, maybe you can learn much more of it while watching the videos or on YouTube of some other people, or like there are many great videos. or you can read the official documentation. It's pretty good for Golang. So, but I will just try to do some basic Golang here, because I'm also learning about that, and this course is not majorly for learning Golang, but I will cover some of it so that you guys have some idea about it. So, I'm doing it just for fun. For example, some people who are already bored with some kind of questions. For example, there are some of you who are watching this video and who have already done this question, but you don't know, like, so this video is not that informative for you. So where is that informative part? You can obviously skip on ahead, like I'm telling everyone. Like, if you find this boring, or if you find like there is no value in watching this explanation, so you can always skip on ahead and watch the part where I do this in Golang, so that you can maybe learn something new. So int n is the grid size, int m is this, so n is the number of rows in the grid, and obviously m is the number of columns in the grid. So it is grid 0 dot size. So grid 0, for the first row, how many columns are there? So since it is a vector of vector, so for the first vector, what is its size? What is the size of the very first vector? And what is the size of the vector of vectors? So it might happen that n is 0. This happens many times in lead code versions. If n is 0, then return 0, because this would else give an error, because you are trying to access something that doesn't exist. So if n is 0, you will return 0. And I have, like, since I've done a little bit of practice, I know that this is a common thing in lead code where they don't specify the conditions. Maybe they have here. Okay, so it is guaranteed that m and n is always less than 300. So yeah, so no need to worry. So this case won't arrive. We can even skip this for now, because we know for sure that n is something and m is something, and yeah, so no problem. And therefore now this thing was separated out. Now simply what we can do is traverse the whole matrix. Yeah, so I should stick to one convention. I think this is better for me. Plus plus I or I plus plus both are equivalent, so it's just a matter of preference. Okay, so and if grid ij is equal to 2, then continue, because we have already encountered this, or I have yeah, we have already encountered this. And if grid ij is equal to 1, then we encountered an unclaimed land. Claim it. By claim, I mean simply start a DFS on that. So we will start a DFS from position ij, and let's pass what am I doing here? So let's simply pass that grid, and yeah, and count plus plus, or we can say that it is the number of islands plus plus. And no need for this, because just we are doing this whenever we encounter n1, because we are obviously then marking everything as 2, and then the number of islands is plus, because as I explained earlier, the number of times we make the DFS call, the number of times we need to make the DFS call, is the number of times we have an unclaimed set of ones. So just claim it or mark it as 2 and increment the number of islands, and simply return the islands. So it is as simple as that. Now the main part is here, obviously. So this is done. It was as easy as it can be. But the main part, as you were thinking, is what is this Dfs function? So what is this Dfs function? And yeah, so let's say we are at index x and we are at or we can simply say we are at index I and index j, and we have a matrix of characters. Obviously you can see the mistake that since this is a character, this must be a character, so whenever we see n1, and yeah, so this is a matrix of characters. So again, let's separate out this n and m, and I uh, if I is less than 0, obviously it's an invalid index, or if j is less than 0, or if I is greater than equal to n, or if j is greater than equal to m, these are all invalid indexes, return 0, or simply return, like no need to go further, no need to recurse further. But if it is not so, then we need to recurse on all the neighbors j grid. And you can see that we are passing the grid by address, we are accessing the same grid, we are modifying the same thing. So obviously one thing is we cannot use any multi-threaded approach here, because since we are modifying the same thing, it might lead to inaccurate results, because the other thread might try to access this other part of the grid which is part of one component, but the DFS call in that component hasn't marked this one as 2, and we are again starting something with the other thread here. So yeah, so this is just an aside thing that you can think of. It's a fun thing to think about. Yeah, so yeah, j plus 1, j minus 1, the previous column, this is the next column, and this is the previous row, and the first one was the next row, the last one is the previous row, and the second one is the next column, the third one is the previous column. And yeah, so you can see that we can just do this call without any worries, because we have handled this out of bounds exception, out of bounds case here. So we are just doing it without any problems. And obviously whenever, the first thing that we need to do whenever we are at some place, we know that since we are at this position, it must be inside the bound, because if it were no, so actually yeah, this is the first thing that we should do. We should check the bounds. If it is out of bounds, then return. But if it is not out of bounds, then the first thing we need to do is mark that grid as 2, else we will just do this infinitely, because if we don't mark it as 2, then yeah, there is no sense in doing anything, because this one will call the next one, and the next one will at some point call previous one, because we are calling the previous column also and the next column also. So they will just like bounce, like the recursive calls will bounce in between them, and it would be an infinite loop, and yeah, out of bounds, like out of bounds, out of time, yeah, it will keep going on. So okay, so this was again something aside, yeah, and so we mark this as 2, and we continue to follow our path. We continue to mark everything as 2, 2, 2, and this call will keep on going. So this was the simple DFS function, and let's try to see whether it runs or not. Let's check whether it runs or not, and there is something wrong, yeah, because it doesn't know where is n and m, so n and m are here. So let's try again, and I forgot one exclamation, like one semicolon. Now there is some other error. So as I said, I will be doing this live, and yeah, even like I make mistakes. I mean, I make a lot of mistakes. So this is some deadly signal error. Oh, I don't even understand what it is and why is it there. And let's try to think why this error might be showing up. So this is something related to some memory thing and some address stuff. So maybe, so it might be the case we are trying to access something which doesn't exist. What can it be? Should be like, because dot size always returns a size type of thing, so size underscore t, so we typecast it to int. But I don't think that this is the problem. This is something that I forgot before, but the problem is something else. Int talents is equal to 0 for this grid ij is equal to, if it is 1, only then start the DFS call and mark the number of islands as, increment the number of islands and return the number of islands. This seems to be correct. And okay, so now I see the problem. Okay, so the problem is that, okay, what is the problem? So it is marking everything as 1. First of all, it is not it is not marking, it is also marking the zeros as ones also, but I don't see why it is an error. I think it should work. If grid, okay, so the error, I see the error. Yeah, so we are not checking anything about the type of the elements. What this code is doing is, as I said, this one will call this one else, and it will call again this one. So that is what is happening. We are not specifying, we just specified the out of bounds condition, and we are not specifying anything about what to do when we already encounter a 2 on the grid. What to do when the grid element is valid. If it is invalid, then simply return. But what to do if it is valid? If it is valid, we are simply marking it as 2, and we continue with the calls. And okay, it will mark everything 2 in the first pass, but it will again backtrack and it will again start marking everything as 2. So now this problem is not occurring, but what problem is occurring is that it is marking the first one as 2, then it is marking the second one as 2, it is maybe marking the third one as 2 also, and then this will see that, okay, mark this as 2, mark this as 2, mark this as 2, then this one will again mark this as 2, and this one will again mark this as 2, 2, and it will keep going on. So yeah, so obviously that was a very silly mistake. I mean, it was the worst kind of mistake. So what to do if the grid element is valid? If the grid element is valid and if the grid element is valid and if it is 0 or it is 2, what does it mean that it is 2? It means that if it has been already visited, since it is already visited, then we don't need to visit it again. So that is again one base condition, so return from that. So this was a very silly mistake, and this code should work now. And yeah, so this is accepted. Let's try to submit it, and this code is accepted. So yeah, this works. Now let's try to just clean up the code a little bit. First of all, we don't need this Dfs function to be public. This was the only public function that was specified, and the main Dfs function that we are using inside this, we don't want to expose it because there is no need. Obviously we can do it, in this case it won't be much of a problem, but there is no need, and if there is no need, why we need to declare it? So better to be safe and declare it as private, because it is a better practice in my opinion. And there are also some variables that are being repeated again and again, and yeah, but I don't think we need that. This is good. And also, this is very ugly, calling DFS multiple times. What if there were diagonal neighbors also? We would have to call +1, -1, I +1, j +1, then I +1, j -1, I -1, j +1, I -1, j -1, like that, all the combinations, and that would be pretty hectic. So let's try to write a loop. Let's call it dx is equal to -1 and dx less than equal to 1 plus dx for int dy is equal to -1 dy less than equal to 1 plus dy if dx is equal to dy, then continue. We don't want that because it means that either they are both same, like 0 0, then we are at the same thing, so no need to visit the same thing again. But if they are opposite, like even then it is wrong. So this is one condition, and if dx into dy is equal to 0, only then, because one of them must be a 0 for this to be like, we don't need to consider the diagonals, so one of them must be 0, as you can see here. And so let's say dy is 0, so dx will be -1, 0 plus 1, but 0 will be invalid because here we are continuing. And yeah, then toward dfs, I plus dx, j plus dy, and on the grid, and remove this, no need. Then run the code, and we will try to submit it again. Like, even if we like remove this thing, so one extra case that we are considering here is 0 0, but you can see that it doesn't matter because if we start the DFS from there, like we have already done the DFS on that, and it was already marked as 2, and now when we are encountering it for the second time, it will see that okay, it is marked as 2, so it won't execute this part here. So even this doesn't matter. The only thing we need to check is that we are not traversing the diagonals. So yeah, because here in this case, like here in this case, if you will be thinking that if the diagonals are connected, okay, then it's okay because this one will be marked as 2, then even the diagonals will be marked as 2. Okay, so it works here, and everything will be marked as 2 eventually. But what will happen here? Here obviously these are two different islands, so we cannot mark the diagonals. It was clearly written in the question that it is horizontal, the lands are horizontal and vertical, not diagonals. So these are two different islands. This is not a single island. Hence even this works. We just need to make sure that we are not like traversing the diagonals, else it would be wrong. But this code works, and this is a short and concise code in my opinion, and I will remove the comments here in the end. Okay, but it's always good to write comments. Yeah, so I think I will keep it. So this is the code, and finally submitting it and checking that it works, and it works. Yeah, so I hope you guys like enjoyed watching this video and learned something new. And yeah, it's okay to make mistakes, but the best thing that we should look forward to is that we should be ready to clarify those mistakes and try to think everything from the very first principles. I mean, like I saw in one of Elon Musk's video that that you need to start thinking from the very first principles. You need to be sure that what are the facts, what are the things that are already correct, and you need to build upon those. Do not start with something very big, something that you have no idea about how you will approach there perfectly, but start with the facts, the absolute truths, the truth and the laws that cannot be modified. Start with those and start building on those, and eventually you will find the correct way. If you can prove it, if you are 100% sure that it's the correct way, then it is the correct way, then go with it. But till then, just try to figure out what you are doing, why you are doing, and where you are going wrong. Like here in this case I forgot that case, like I forgot this condition, how silly of me. So I forgot this condition, and yeah, don't do that. So thank you for watching this video, and hopefully we will cover another good question in another video, and I will see you again. Thank you.